is a function that graphically symmetric over the line y equal to x equal to 0. That's also mean the y-axis. That's just what it means. Okay, so you're going to have a function that, like this one, you guys see that it's symmetrical. That means as you flip this piece over the y-axis, you get the same thing over here. Yes, that is what it means to be symmetrical. Now, what does it really mean in terms of like the notation? And this is what it means. And if you look at this and you're like, Ms. Sharon, I have no idea what that is. Well, you know what this is. That's x. So you have x here, and then you have negative x here. This is f of x. F of x is y. What this tells you is that the y value of x is going to be the same y value for the negative x. That's what makes it an even function. I'm going to give you an example so you can see it. Is that okay? These 2 points are what this is. This is an even function. So for example, I'm going to pick a point. I'm going to pick this point. And I'm going to pick this point because I can count them. These are like these 2. Okay? This point is 2, 4. This point is negative 2, 4. Now, do you guys see that while your x is the opposite of each other, your y is the same y value? Do you guys see that? That's what it means to be an even function. So when you plug in a positive number or a negative number, you get the same y value. Is that okay? That's what makes it an even function. So this point reflects over the y-axis. So the y value for x is the same as the y value for the negative x. Is that good? That's what makes it an even function. Now, an odd function is graphically symmetrical to the origin. Okay, this is where things get tricky. An origin means you got to reflect it over the origin. Okay? And here's the relationship. The y value of x, yeah, is the negative of the y value of negative x. So what that means is your y are no longer the same. They are the opposite. They have opposite signs of each other. So for example, if I'm looking at, let's say this point, this is an odd function. Let's see, is there a point that I can sort of see? Well, let's call this point, let's pick a point here. So that's going to be what? 1, 2, 3, 4. I'm going to get a coordinate. I guess this can be like 2.3, comma 1, 2, 3, 4. Let's put that point there. This point is going to be negative 2.3, negative 4. So what you can see is that your x value are the opposite of each other. Your y value is also the opposite of each other. So one is positive and one is negative. That's what makes it an odd function. Yes? A lot of us, we look at odd function in terms of degree. Like if it has a 3, that's an odd function. Or if the degree is 2, that's an even function. No, it's not. An even function by definition here is a function that is symmetrical to the y-axis. Are we okay? Now, what is not symmetrical to the y-axis and is an x squared function? I'll show it to you so you sort of understand it, okay? If I take this function and I move it over, yeah? Now that is no longer an even function. Are we okay? Ms. Tran, how come it's not an even function? Because when you take this and you reflect it over the y-axis, you gotta see something over here. There's nothing over there. Do you guys see that? So that's not an even function. It has an even degree, yes, but it's not an even function. Does that make sense? There are two different things, okay? Even degree or odd degree. symmetry does not mean you have an even or an odd function. Is that good? Even function means it has to symmetrical to the y-axis. If I draw this, there's nothing over here. So if I flip it over, there's nothing here. So there is no symmetry. Does that make sense? Yes or no? Okay. Now, go to the next page. This is going to be the last example for 1.5. I want to determine whether the function is even, odd, or neither. Okay? I don't have time to graft. Are you guys good? So I want to know, is it even or odd? There are two ways to do this. Okay? The most easiest way is you pick an x and you plug it in. And then you take the negative of that x and you plug it in. If they give you the same y value, it's an even function. Yeah? If you get the y value, they're the same number, but one is positive, one is negative, then that's an odd function. Is that good? That's one way to do it. That's the easiest way. Now, the other way is you just have to plug in the x and the negative x. And that's what we're going to do because we're in pre-calc. So we're not going to go with numbers. We're going to go with abstract variables. So this is how you're going to check. You guys see that the cool thing when you use the variable is that this is already x. So you already have the x value. So now you just have to check f of negative x. Okay, because I already have x. Okay, so this is already given. There's my x. Okay, so now if I plug in a negative x into here, would I get the same thing? Yeah, so let's check. I'm going to write my x using parentheses like this. And then I'm going to plug in my x. So that's a negative x. That's a negative x. Let's clean this up. Here we go. If you take a negative variable to an even power, what do you get? What's a negative x to the fourth power? Remember I told you that any negative to an even power will be positive. So your answer is x to the fourth. That is have to be clear. If you don't know, this is what you should be doing right now. Negative times negative is a positive. Negative times negative is a positive. So you have positive times positive is a positive. X times x times x times x is x to the fourth. So that's why you have positive x to the fourth. There's no more negative. Is that good? But we're not going to sit there and do that. So please remember, a negative to an even power will change to positive. Okay? Here we go. Same thing. Let's do the next one. I have a negative 2. A negative x to an even power will be positive x squared plus 5. Now compare the two. This is your y value. That's this. This is your y value for f of x. This is your y value for f of negative x. Check each term. Are they identical? Yes. That means this f of x is equal to f of negative x. So therefore, this is an even function. So we write f of x is an even function. Okay. Please know that these are somewhat confusing. I get that. So if you are doing something else when I teach, it's not going to help you out. Okay? You got to make sure you ask. And if you like, Michelle, I still don't understand, then I can show you something else. This is one way to do it. Another way to do it, like I told you, this is the simplest one. You pick the number. Okay? Don't pick 0, because 0 kind of, it's a special number. Okay? 4 minus 2 times 2 squared plus 5. So this is 16. That's going to be 4 times 2. It's going to be 8 plus 5. The reason we pick small numbers is so we can do mental math. Yeah, you don't have a calculator to do this. 16 minus 8 is 8. 8 plus 5, that's 13. Everybody okay? Yes? Next, I'm going to pick the opposite of that number. I'm going to pick negative 2. You have to because it's either x or negative x. You guys see that? This is your x. So now I'm going to pick f of negative 2. So now my number goes from 2 to negative 2. Negative 2 to the 4th minus 2 times negative 2 squared plus 5. Negative 2 to the 4th is positive 16. Negative 2 squared is 4. Times negative 2 is negative 8 plus 5. You guys see that they're the same. So therefore, the answer has to be 13. So while your x are negative, your y is the same. That's symmetry right there for the y-axis. Is that good? So, Ms. Shan, can I do this and not that? Yes, you can. Just don't pick 0. Don't pick 1. Because those are like identities in most cases. So don't pick that. Is that good? Pick something else. Are we okay? Does that make sense? Okay, let's do the last one, and then the rest of the time is yours to do your work. All right, but you speak up. If I give you this example and I explain it this way and you're like, I don't get it, Ms. Tran, you ask me. If I have another way, I can show it to you. Is that good? If I don't have it, I'll try to find out and then I'll show it to you. But if you stay quiet in this class and you're like, I don't get it, you're going to get screwed, okay? All right, let's do the next one. I want to check whether the function is even, odd, or neither. So this is already given. I am not going to touch that. I'm going to check the negative 1. So I'm going to check G. This is G now. Oosh. This is G. Now I want to plug in the negative of the x. So now I have 5 x to the 5th power plus 2, and then x to the 3rd plus the x. So every time I see x, I'm going to put parentheses. That's a negative x, a negative x, a negative x. All right, so what do I got? This is a 5. What is a negative x to the 5th power? Negative x to the 5th. So there's a negative because this is an odd power. Do you guys see that? Because there's a negative, I want to put the negative in front and then x to the 5th. Because the negative times 5 is negative 5. Are we okay? Now I'm going to write the 2 here first. I'm not going to write the plus because I can see here that a negative x to the 3rd power, what is that? What's negative x to the 3rd power? Negative x to the 3rd. Is that good? Your value is going to be negative because you're going to have 3 of the negatives, right? So if I time that with the positive, that's going to be negative, and then x to the 3rd. And then this is going to be negative x. How are we doing? This is how you check. Check each term. Do you guys see that this term is a positive x to the 5th? This is the opposite of that. That means they are negative of each other. So that term is good. Next term. They're not the same. They are the opposite signs of each other. Next term. They're not the same. They are the opposite sign of each other. Because they are the opposite for each one of them, this is an odd function. Do you guys see that? Yes? Because all these values are negative. Now, Ms. Tran, what if this one is negative? What would this be? It have to be positive. Do you guys see that? It have to be negate the negative of the other one. Clear? That's how you know this is an odd function. The odd function is when this is your y value This is your y value when x is negative. Is equal to the negative y value of x. So your y value have to negate each other. It have to be negative of each other. So if this is positive, that term have to be negative. If this term is positive, the other term have to be negative. That's how you know that they are odd function. Oh, this is g. Let's change this to g, my bad. How do you know if they're even? They're exactly the same. See? X to the fourth, x to the fourth. X squared, negative x squared, negative x squared. 5 and 5. So this is odd. Okay? Now, I'm going to give you one. I'm going to show you that if I put in something here, this will no longer be an odd function. So I'm going to show you that so you can see the difference. Is that okay? If you don't believe me, you can always plug in the number and check. But let me show you, yeah, that by just changing one thing, this is no longer an odd function. So you can see the difference between the two. Okay? If my function, this is good, is, let's see, 5x to the fifth, I'll keep that. 2x to the third, I'll keep that. And next, yeah? What if I put a number at the end? That is no longer an odd function. Okay? Now, let's check to see why it's not an odd function. You guys okay? If I put a negative here, then you guys agree with me that would be, well, let's show where. Let's show where. So this will be negative 5x to the fifth. This will be negative 2x to the third. This will be negative x plus 2. You guys okay? Okay, now watch. This term and this term, they're the opposite. Good, check. This term and this term, they're the opposite. Good, that's checked. So far, these are odd function. You guys see that? This is positive x, this is negative x. They are the opposite. We're good. There you go. That's not opposite. They both plus. You guys see that? If it's the opposite, this have to be a negative 2. You guys see that? However, I don't have an x here to change that to a negative. You guys see that? That's why this is no longer an odd function. Does that make sense? Yes? Okay? Because they're not the same. Yes? Question? Okay, we are done. Let's go on to your homework. Let's try 1.5 number 1. You guys try that first, please. Yes. Let's go to your 1.5, please. Go. Thank you. Okay, I'm gonna close this up. That's done. Let's go to 1.5, number 5. Why don't you try that problem 1 first for me? Try problem 1. Discuss that with your classmates. See if you can eliminate any of those answers first. Hint. Make sure you see, think about multiplicity. Yeah. Also, and behavior. Hey, what kind of polynomial is this? what should this kind of polynomial looks like. Okay. Let me give you a hint. I'm going to write right here. When you have polynomial, it is important that you know the degree. Okay? The degree is the highest exponent that you're going to have. So if your degree is an even degree, we're going to call it even polynomial. I don't say even function. That's different, okay? Even function is when you have symmetry. Even polynomial is when you have like x squared. Is that good? That's the highest exponent that you have. Or x to the fourth. Or x to the sixth, etc. Is that good? Then your function, either both ends go up or both ends go down. That's an even polynomial. For an odd degree polynomial, this is the degree, okay, that we're talking about. For an odd degree polynomial, that means you have like x cubed, that's the highest exponent that you have, or like x to the fifth, or x to the seventh, etc. Then your function, one end go down, the other ends go up. Or vice versa. The left end go up, the right end go down. So these are your possibilities. Okay? You talk about that in Math 3. Use this to see if it helps you eliminate some of these. And also the multiplicity. See right there, the multiplicity. Okay, so let me ask you this, okay? Let's talk about multiplicity. Based on this, what do you think, yeah, you can eliminate? Okay, so let me ask you this way then. We don't know that, all right. We talk about polynomial, even degree polynomial and odd degree polynomial. Do you know what kind of polynomial this is?